What's up guys, it's your boy Dwayne Howell and we are back again. So for today's video guys, so we are going to make JK&D flip-flops on our breadboard. So ano pa hinihintay natin? Tara na! This is our equipments and materials. 5 volts DC power supply. Our 74LS00 or NAND gate. 3 pieces. 5mm red LED, our SPDT switch, connecting wires and jumper wires, of course, our breadboard. So let's start mga buddy. So first, let's put our IC. So based on schematic diagram, 1 and 2 of IC is connected. So 1 and 2. And number 3 is connected to number 12. 1, 2, 3. It's connected to number 12, 14, 13, and 12. For our next step, we will put our switch. Based on schematic diagram, our D1 or switch is connected to line 1 and 2. So we will get jumper wire and we will connect it to line 1 and 2. So we're connected now. And for our next step, number 11 is connected to number 9. So we will get these connecting wires. 8, 9, and connected to number 11. So they are connected now. And number 8 is connected to number 13. So this is number 8. And we will connect it to number 13. They're connected now. So for our next step, we will put jumper wires on our switch. So the third pin of our switch is connected to the negative side of our power supply. So I guess I put it here. And the first pin is connected to positive side. So yeah. And we will put now our pin 1. So in 1, I guess I'll put it here. So in 1 is connected to line 1 and 2. So this is line 1 and 2. We connect it to in 1. And the negative side of our LED or in 1 is connected to the ground. And in 1 is connected to number 10. So we will connect our in 1 to number 10. So this is number 9. And we will connect it to number 10. And line number 1 and 2. So yeah, they're connected now. And for our next step mga buddy, we will put our in number 2. So this is our in number 2. Same procedure. And number 2 is connected to line number 11. So this is number 11. So we will put again the negative side of LED to our negative side of our power supply. So and then we will add our in 3. So that's our in3. So our in3 is connected to number 8. We will connect it to number 8. And the negative side is connected to the ground. Now, for the last step, the number 14 of our IC is connected to positive side. So that's our circuit 1. So let's check what will happen to our circuit. So let's open our power supply, and yeah, based on truth table, if D1 is on 0, our in3 is on high logic, and our in1 and in2 is on low logic. So let's change our D1 to high logic. So as you can see guys, our in1 and in2 change to high logic, and our in3 is on low logic. So that's our circuit number 1. So let's move on to our circuit number 2, or JK flip-flop. So let's start. So based on the schematic diagram, we have 2 AND gate and 4 NAND gate. So we will change the number of inputs to number 2. Oops. Number 2. So for our next step guys, we have this on our schematic diagram. We have 2 inputs, the D3 and D4, and we have another input which is clock pulse. So you can see it on the wiring and the clock pulse. So based on schematic diagram, so the output of our first AND gate is connected to our first NAND gate. So they're connected, and our AND gate is connected to our clock pulse, and the NAND gate number 1 and 2 is connected. So we will connect them. So for our D3, we will connect it to our NAND gate. So for our next step guys, our D4 is connected to our second AND gate, and the output of our second AND gate is connected to second NAND gate. So let's proceed guys. So our second AND gate is connected to second NAND gate. So the output of first AND gate is connected to third NAND gate. So they're connected now. And this AND gate is connected to this NAND gate. And we will connect this NAND gate to this NAND gate, to the output of this NAND gate, and oops, this is wrong. We'll change it to second input, and this we will connect it to the output of this NAND gate. So this AND gate is connected to this NAND gate, and this AND gate is connected to this. So we will put out now our outputs, which is LED. So we have in 4, in 5, in 6, and in 7. So overall, there are 4. So this in 4 is connected to clock pulse, and the in 5 is connected to D3, and in 5 is connected to D4, and now the in 7 is connected to this line, and we will put output here and here. So that's our circuit, or circuit number 2, or JK flip-flop. So let's see what will happen if we turn on. So switch on the D4, K input, and what happens to the output. So we will switch on our D4. So this is our D4. So we will switch on. So as you can see guys, the D4 is on high logic now, and the output is on high logic, which is the in 6. So switch on the D3, what happens to the output. So we will switch on the D3. So this is our D3 guys, and we will turn it on. So as you can see guys, our in 5 is on high logic now because we turn on the D3. So switch off D3, and what happens to the output. So we will switch off this D3, and let's see what will happen. So we switched it off. So as you can see guys, our in 6 turns to low logic. So switch off D4 and repeat steps 7 and 8, that is switch D3 on and off to observe the effect. So we will turn off our D4 guys. So and repeat step 7 and 8. So 7 and 8, switch off D4, I mean switch off D3, and what happens to the output. So then guys, if we switch it on, our in 5 will be on high logic, and if we switch it off, our in 5 will become low logic. So yun guys, that's our JK flip-flop.